Hi guys, welcome to my YouTube channel. In this video, let's learn a Python program, that is write a Python function that prints the prime factors of a number recursively. So given a number, so you have to print the prime factors of a number. So you have to use a Python function, and also you have to use a recursive method to print the prime factors. So now let's understand what exactly is a prime factors of a number. So here I have taken a number that is 27. So this is my sample number. So index I have starting from 2. So this is a number that I'll take and try to divide it 27. So if we take the index, that is a starting value, as 1, so it can completely divide, and yeah, so any number will have a factor as 1. So instead of that, so we will be starting it from 2. So this will be a prime factor. So let's take the number that is 27 and try to divide it by 2. So here you get a fractional part as a quotient. So what you do is just increment the index, that is 2 plus 1, that is 3. So we get incremented by 1. So here, so let's try take a number that is 27 and try to divide it by 3. So we got a quotient as 9. So in the quotient, so let's take a quotient again and let's try to divide it by 3. So you get again the quotient as 1, and again you take a quotient and try to divide it by 3, that is the index, and you get a quotient as 1. Since you got a quotient, so this is the end condition of the program. So yeah, so you have to exit the function. This is not a program, this is a function, by printing 333 as a prime factor. So you can see that is 27 can completely divide 3, again 9 can completely divide 3, and 3 can completely divide 3. So you get a quotient as an integer and not a fractional or floating point. So this is how you try to find the prime factors of a number. So this is a manual method. So let's try to solve this using a Python function. So let me define a function that is prime underscore factors. So this is my function definition. So we have to pass two values. First is a number and the next is a index value. Yeah, so let's try to define the Python function statements. So first we have to check if the number is equals to 1. So this is refers to if the quotient is 1, so you have to exit the Python function. So let's use a return statement and let's return 0. So now else if number is non-zero or greater than 1, so what you do is, that is number is not equals to 1 or greater than 1. So you have to check if the number is completely divisible by the index. That is completely divisible, you have to use a modulus operator to get a remainder. So if the remainder is 0, so that is not a fractional part. So let's print the prime factor. So you have found a prime factor, that is index. So we are printing a index, that is a prime factor. So yeah, again you have to call the, that is a Python function recursively, so that the quotient becomes, that is 1. Yeah, so let's take again prime factors and you have to perform true division, that is number true divided by the index. And yeah, so let's pass the index value over here. So this is for when you find a prime factor of a number, so you just pass the index. So if you don't find the prime factor, so then what you have to do is just call the number, that is call the Python function, that is a prime factor, and pass the number and increment the index. So here instead of the, that is instead of remainder is 0, so you got a quotient as fractional part. So here you are handling the fractional part by incrementing the index. Yeah, so this is a complete Python function that prints the prime factors of a number. So here you are printing the prime factors since you find a non-fractional part. Yeah, so in the main program, so let's take a variable n. So this is an integer type variable and use the input function call, and let's ask a user to enter a number. Yeah, so once the user enters a number, so let's convert these to an integer using type conversion from string to an int. And let's print some user-friendly message, that is the prime factors of a number n is dot dot dot. So let me copy and paste it over here, and let's use print formatting, and here you have to give f is dot dot dot, and yeah, so let's call that is a Python function. So let me copy this and paste it over here, and we have to pass n and 2. Yeah, so this is how you try to call a Python function recursively. So let me run this and let me show you how it works. So enter a number, so let's give 27. So you can see the prime factors of a number 27 is 333. So the same sample input number that I have taken for explanation. Let me run it again. This is the second time. So let's give 315. So you can see the prime factors of a number 315 is 3357. Running it again. So let's give something like 1000. So you can see the prime factors of a number 1000 is 222555. Yeah, so this is a complete Python function that prints the prime factors of a number recursively. So I'll give this code in the description of this video. So that's it in this video. Hope you liked it. Thank you for watching. Bye.